Good morning, everyone. Good evening, good afternoon, wherever you are. Just bringing you a little update here on our current affairs. Right now, we're taking a look at the ionosphere. And as you can see, our Coriolis effect is having a battle here with other magnets. In the North Hemisphere. Let's go down to our jet streams. Look at this jet stream, everyone. Yeah, look at how it breaks right here. Now let's check out our surface. This is about 10 to 20 feet from the ground. And look at that, y'all. Look at all this pressure that's been compressed down to our surface. Look at this. Look at how long we've been watching this one right here. And all its funkiness. Let's check out some waves. Yep. Continued swelling on all west coasts around the globe. Still on fire. And little red dots is fires, everyone. Look at this. Gosh, that's a lot of fire. And down here we're having all these quakes, floodings, natural disasters happening in this area. Let's find our UV index. So we got a UV of 15, 16, 14, 13, 14. Yep, that's pretty dangerous UV there. Now let's see if we can get everything back. go. Back up at the ionosphere level. Let's go over some known facts here. Coriolis effect. This is straight from NOAA. It says here, if the Earth did not rotate on its axis, the atmosphere would only circulate between the poles and the equator in a simple back and forth pattern. Now, because the Earth rotates on its axis, circulating air is deflected toward the right in the northern hemisphere and toward the left in the southern hemisphere. This deflection is called the Coriolis effect. So, with that little bit of information there, how do we explain this one right here? This one's going to the left in the northern hemisphere, right? Here's Africa. Here's England and Europe, so that's northern hemisphere. Here we got wind going towards the left. By definition, this is a southern hemisphere storm cycle. What's it doing on the north? Ekman spiral. This is something that was directed from this page here. Let's continue reading. Coastal currents are affected by local winds. Surface ocean currents, which occur on the open ocean, are driven by a complex global wind system. To understand the effects of winds on ocean currents, one first needs to understand the Coriolis effect and the Ekman spiral. So let's check out this spiral. So it says here, this spiral occurs as a consequence of the Coriolis effect. The Ekman spiral, named after a Swedish scientist, von Walfrid Ekman, who first theorized it in 1902, is a consequence of the Coriolis effect. When surface water molecules move by the force of wind, they in turn drag deeper layers of water molecules below them. Each layer of water molecules is moved by friction. Friction, huh? A lot like magnetics friction. From the shallower layer. And each deeper layer moves more slowly than the layer above it, until the movement ceases at a depth of about 100 meters or 330 feet. So, with that being said, let's check out our waters. That looks like it's going to the right now. Or how about this one? This one, it's going, it wants to go right, but it's going up and around towards the left. Same thing over here. This is getting pushed this way. Starting here, comes down and out towards the left. Crashing on the west coast. I'm sorry, on the east coast over here. Malaysia over here. Japan. So yeah. Why do we have southern hemisphere storm systems in the northern hemisphere? Oh gosh, cold coffee is great for an update. So here we got our tremors. As you can see, we are tremoring like a ringing bell around the globe. Because that is how our waves of all matters travel. They need something to bounce off of. It cannot be flat for these waves to travel. And what we're observing here is magnetic braking. As our axis keeps shifting, this will continue. Pretty sure you guys got the idea. We're shaking. Look at that Turkey with another earthquake. It looks like it wants to stay on that ring of fire, but it's spreading further off of that ring. Look at here, down in the Gulf, into the Atlantic. We've already had this many earthquakes within the past 24 hours. Look at this guy. The location of this guy. Back on the Knoll School. That area's messed up. And about 15 atomic bombs of equated seismic energy around the globe. Now, my favorite part. So happy that it actually loaded. Past few days before my little storm system rolled in, I wasn't able to get much off of Issawa. But as you can see, we have a lot of closed field line activity in the front and back. More so in the back. Little induction at the South Pole. Look at how far this closed field line developed right here. So we got nothing but polar caps behind us. Now, look at the moment she stopped sucking off the bow shock to close field line. Look at that. Bam. And pushing. Look at that IMF line. It's not ours. More closed field lines. That's heavy, heavy bodies behind us. Look at that. Look at those closed field lines, the red lines. scrunch up like a broken spring. Right there. Look at this zero right here. This zero right here is our ecliptic. I'll draw an invisible line from that zero straight across to our planet here. And look at how many bodies we encounter. We got one here. We got another one there. Looks like two right there. So that's already 3, 4, 5, 6. 6 bodies on a channel right there. More. Gosh, that's a lot of closed field lines. And look at this body just between -20 and -40. Down here, you see this right here, -20, -40. And go straight up right here. In the center of our screen here. With our red lines. See how it wraps around like a coil. It's a closed field line, indicating the presence of another magnet. And look at the wind being deflected behind us off of these bodies. The change in arrow direction. Here, isn't it, I guess you could say, a zoomed in view of this compression, magnetic compression, both in front and behind. This is what's influencing everything on our ionosphere back on Null School. Remember all of our counterclockwise swirls that are swirling to the left? That should only be in the southern hemisphere. Yeah. This is why. It's not because of this guy. You know, no one wants to admit why this guy is getting so excited that he can't contain himself. You know, I think there's a quite notable verse in the Bible that a lot of people like throwing around about Isaiah 24:23, talking about confounded moons and an ashamed sun. Well, to me, this looks like a pretty ashamed sun that he can't control his own frequency. He's got to be coming out of his solar minimums, as these scientists call. Now, what would make a magnet of this frequency lose its cool? It's because there's another sun that's closing in on us, or we're closing in on it. Or we may be closing in on each other. You know? Now, for those who may have a hard time with anything, here's something fun. Thank you, Homebrewed, for giving some search terms here. Thank you, Catfish, for the same. Here we got hemisphere specific views of the moon. Now, a lot of people might not know this. Some people even go out of their way to tell people that what we're looking at here is normal. So, it says right here from planetary.org. Did you know that the moon looks different from Earth's northern and southern hemispheres? Someone looking at the moon from our North Pole would see it upside down compared to someone seeing it from the South Pole, and someone on the equator would see it at various orientations throughout the day. Oh, really? Now, why is it that we have a northern hemisphere observer here with Tycho crater being all over the place? Look at this one right here. See, we got our man upside down. Man upside down. Why is someone in the northern hemisphere viewing a southern hemisphere moon? This person in the northern hemisphere obviously did not record themselves viewing the moon while crossing the equator. This was done from one fixed location. We did not travel on a boat. We did not travel on a plane. But I will say that our North Pole has been influenced by all these bodies right here. That Catfish, Homebrew, myself, recently have been trying to bring to awareness that there's stuff out there that they don't want us to know. With that being said, everyone, I love you all. I wish you all the safety to make it through this. Thank you all for your time. I appreciate every single one of you. Thank you all. Love you all.